Hello, and welcome back to Teaching Statistical Thinking. My name is Catherine from Duke University. The last time we met, we explored the relationship between two categorical variables using a mosaic plot and a contingency table. In this video, we will explore the relationship between one categorical variable and one numeric variable using side-by-side box plots. In this example, the variables that we will observe are the MSRP, or price of the game, and the ESRB rating of the game, such as T for teen and E for everyone. So let's begin. First, we will go to Analyze, Fit Y by X, and place MSRP in the Y response box, and ESRB rating in the X factor box, and click OK. Now we have our graphic. First, let's add box plots, number summaries, and remove any unwanted indicators. I will go to the red triangle, select quantiles, and select means and standard deviations. Go to display options and unselect mean error bars and standard deviation lines, and select histograms. We now have a better view of this relationship. First, we have our grand mean line, which is at about $38.40. This line is the average MSRP of all our observations. If we look at our histogram, we see that the distributions of all three ratings versus game price are unimodal and unsymmetrical. But the first thing that you may have noticed is the outlier in the distribution of E. Nintendo's Wii Fit was released in 2007 at a MSRP of $89.99. This was really high, considering that 75% of the 27 video games rated E were priced less than $39.99 and mostly cheaper than games rated M or T. Just in case you wanted to know, this high price was due to the high-tech balance board peripheral that the game is equipped with. Now I'm going to exclude this outlier from our set of observations to see any change. To do this, I will right-click on the outlier and select Exclude. I will fit the relationship again. As you can see, the removal of Wii Fit caused our mean and standard deviation to decrease, as well as our grand mean, to about $37.68. Now, if we look at the 13 games rated M for mature, we see that the middle 50% of these games were priced higher than $39.99 as compared to our other two categories. So, these games also had a higher mean MSRP than those rated E or T, as well as the grand mean. The middle 50% of the games rated T for teen ranged in price from about $18.73 to $42.49. Now, let's quickly summarize the MSRP-ESRB rating relationship. Rating E has the lowest minimum price and the highest maximum price, but without the outlier, rating M has the highest maximum price. Rating E has the lowest median price, and rating M has the highest median price. The same applies to the mean price. Rating T has the smallest spread, and rating E has the largest spread. But without the outlier, rating E has the smallest spread, and rating M has the largest spread. Lastly, is the content rating of a game associated with its cost? 17 out of 27, or 63% of games rated E, were below the grand mean MSRP. 11 out of 13, or 85% of games rated M, were above the grand mean MSRP. And 4 out of 6, or about 67% of games rated T, were also above the grand mean MSRP. So it seems that there is a clear association between price and rating, as a greater number of games rated M and T cost more on average than those rated E. That's it for our exploration of the relationship between one categorical and one numeric variable. In the next video, we will analyze the relationship of two numeric variables using a linear regression model.